Very good morning to everyone. In this lecture, EC 8791 Embedded and Real-Time Systems. In previous session, in Unit 4, we have discussed the task assignment and scheduling process in embedded system design. Now, today, we are going to discuss the fault tolerance systems in embedded system. First of all, the definition of the fault tolerance. The fault tolerance is the property that enables a system to continuous operating property in the event of failures of some of its components. So, the fault tolerance is related to dependability. The dependability include the availability, reliability, and safety and maintainability. Now, what is the availability functions? We can see the availability. It is a measurement of whether a system is ready to be used immediately. And the reliability referred to the property that a system can run continuously without a failure. And then safety, a measurement of how safe failure are to be measured. And the maintainability, it is a measurement of how easy it is to repair the system. And the testability, it is measure for the each of with certain attributes within a system can be tested. And also the failure of the system, a system is said to be fail when does not behave as promised. And also what are the characteristics, what are the category of fault tolerance? It is a long life applications, examples space and satellite, and critical computation applications, and also the example of critical to human safety aircraft control system. And what are the maintenance or postponement of application? For example, space system and remote processing system, and high reliability applications, example for banking and flight reservation systems. So we can compare the type of failures and what are the description. In the failure, the server halt but it working correctly until it halt. And the omission failure or receive omission or send omission, a server failed to respond to incoming request, a server failed to receive incoming message, and a server failed to send a message. And then the timing failures, a server respond lies outside the specified time interval. And also the response failure, value failure, and static transition failure. The server respond is correct, the value of the respond is wrong, the server deviates from the correct flow of control. So you have to see the design flowing of fault tolerance techniques in embedded system design. First of all, we have to select the hardware architecture model in the correct network topologies, and also the convenient software architecture model. It is what type of the components we are interfaced with the modules, and also the fault modules. It is a expected modules, fault module, and a effect on hardware and software components. So these reliability and availability have been become increasingly important today in many the applications where the computers or other embedded modules. So the malfunctions can be expensive, even the distractions. So just imagine the computer system in nuclear plant manufacturing, or the computer system in space suited booting just when the shuttle is about the land. There are the more examples. It is a fault tolerance in computers machines. So the environmental, the user and the service cost and large systems are there. It's a hard starving environmental. The computer operate in clean computer room with a stable climate and a clean air. It is a industrial environmental. It computer move outside of the industrial. So we can select the fault tolerance methodology using the software or hardware in embedded system design. It is a service cost and the larger system capability, that is operations. It produces and the activities of the normal system configurations and the network module software instructions. So the system or module is designed, it is a behavior of the specified services, and it is different from the specified behavior. So we can call it it is a failure. So the failure occur because of an error, it caused by a fault. The time between the occurrence of an error and the resulting failure is the error latency. So, to achieve a reliable or higher available system, two very different approaches can be used. That is a fault avoidance and fault tolerance. While fault avoidance is a prevention of the fault occurrence by construction, fault tolerance is the use of redundancy to avoid the fail due to the fault. The fault avoidance is difficult and close to impossible in large and complex systems. So this fault tolerance the only for a realistic alternative for the large and complex systems, and it is a general purpose of different embedded system, design methodologies. So the error correction reduce the failures by using the redundancy to tolerate the fault. That is a latent error processing. It is tied to detect and repair the latent errors before they become effectively. An example is preventive maintenance, that is a effective error processing tied to correct the error after it become effective. This can be done by masking or recovery. It is a correct, it is a error correction code. So the recover is requested the services and a set of modules to the error free state. We have to form of recovery backward and forward recovery. The backward recovery return to correct a previous state. This can be check up the restart when which means that the state is stored at a regular interval. At the restart time, the last storage state is loaded, and the restarted from while the forward recovery, and a new correct state is constructed. Example, by the resending the message or rereading the disk pages. So, in this recovery, there are the two different kinds. That is the fault models. So there are the four different redundancy used in fault tolerance system. There are the hardware redundancy and information redundancy, software redundancy, and time redundancy. In hardware redundancy, it is a interconnection reconfiguration to avoid the connection failure to be fatal. The interconnection reconfiguration can be provided. This is easy to provide if the system is already used in some kind of interconnection that have alternatively path between the modules. For example, is a computer connection in the hypercube network. Even in the network connection is failed, so the message can be rerouted via other connections. Another one is watchdog timer and timeout. Watchdog timer and timeout are used for keeping the track of progress. A watchdog timer should be reset within a certain amount of time, and is not a failure is assumed to have the occur in timeout, are also based on the principle that operation should not be possible. So then the information redundancy. The information redundancy is the addition of the extra information to data to allow the error detection and correction. This is a typically error detection code, the error correcting code, and the self-checking circuits. Then the error detection code. The parity code are used in most modern computers for memory error detection in related to embedded system. So this is a simple code that does not require much additional hardware. That is another more advantageous code is M of n code. This is a code that required code word to be n bit of length and contained exactly m once. To check the arithmetic operations, and the arithmetic code can be used. So the code can also be error correcting. The data encoded with the error correcting code can contain the error, but it contains redundancy to recover the data. So in this lecture we have discussed the fault tolerance techniques in embedded system design modules. Thank you for watching this video.